This is a review section for chapter 3, lots of problems from all sections. Okay, 3.11, loop number 13, prove hyperbolic cotangent squared x minus 1 is hyperbolic cosecant squared. Okay, so hyperbolic cosecant squared is 2 over e to the x minus e to the negative x squared, which is 4 over e to the x minus e to the negative x squared. The left-hand side, hyperbolic cotangent is e to the x plus e to the negative x over e to the x minus e to the negative x squared minus 1. So I'll write this as e to the 2x plus 2ab, 2 times that is just 2, because that times that is 1, plus e to the negative 2x. That's e to the x minus e to the negative x squared. This is 1 in the form of e to the x minus e to the negative x squared, so I can get a common denominator. Okay, so this is e to the x plus 2 plus e to the negative 2x minus parentheses e to the x minus 2 plus e to the negative 2x. Again, the 2ab term minus 2 times that, but that times that is 1. Okay, that cancels out, 2 minus 2 is 4. Left-hand side matches the right-hand side. 3.5, number 15, ask for dy dx, e to the x over y equals x minus y. Treat this as e to the x, y to negative 1. So derivative left side is e to the x, y to negative 1 times the derivative of the exponent, which is first times derivative second, plus second times derivative of the first. Okay, so negative y to negative 2, dy dx, should be an x here, plus y to negative 1, and derivative of this is 1 minus dy dx. Cleaning it up, negative e to the x over y squared dy dx, plus e to the x over y plus over y equals 1 minus dy dx. Put this over here, put that over there, dy dx, factor out, 1 minus e to the x over y divided by y squared equals 1 minus e to the x over y divided by y. Divide both sides by this mess, and you have this. That's sort of the answer, but make it cleaner, multiply top and bottom by y squared. So dy dx is y squared minus y e to the x over y divided by y squared minus e to the x over y. In 3.613, g of y is ln of all this stuff. It's a lot easier if you clean it up first. Ln of a quotient is ln of the numerator minus ln of the denominator. Bring the 2 down, bring the half down. And so it's much easier to differentiate this. So g prime of y is 2 times 1 over 2y plus 5 times 2 plus 1/2 1 over y squared plus 1 times 2y, etc. Easy cleanup. Just 2 times 2 is 4. Cancel that out. That's that. 3.554, inverse tangent of that. The derivative is 1 over 1 plus this thing squared times the derivative of the inside, which is 1 minus 1/2, 1 minus x squared to negative 1/2 times negative 2x, and just etc. Just some cleaning up after that. See 3.1135. Derivative of sinh ln t is cos ln t times derivative of ln t, which is 1 over t. So this is the best final answer. Okay, 7. Prove that sinh of negative x is negative sinh x. This is e to the negative x minus e to the negative x all over 2, which comes out to be e to the negative x minus e to the x over 2. The opposite of this, I can just turn these around. I have e to the negative x minus e to the x over 2, and there we are, the same thing. 3.315, theta, cos theta, sine theta. It's a product of 3 terms. I'll treat this as a first, and this is the second, but when I get to the point of differentiating this, it also requires a product. So first times derivative of the second, cos theta, plus second times derivative of the first. Derivative of the first is a product, so theta, negative sine theta, plus cosine theta, and that's a little bit of touch-up. 3.517, inverse tangent of x squared y equals x plus xy squared. Differentiate implicitly, 1 over 1 plus x squared y quantity squared times derivative of this implicitly, so x squared dy dx plus y times 2x equals the derivative of the right side, 1 plus x 2y dx plus y squared. Distribute x squared over 1 plus x to the 4th y squared, that's what that is. Distribute the dy dx with the x squared plus 2xy over 1 plus x to the 4th y squared equals 1 plus 2xy dy dx plus y squared. Put all the dy dx's on this side, move this over here, factor out the dy dx, x squared over 1 plus x to the fourth y squared minus 2xy. And this becomes 1 plus y squared minus all that. Divide both sides by this. And this is essentially what you have for that one. 3.421, y equals square root, which means this thing to the half. So the derivative is 1/2 x over x minus 1 to negative 1/2 times the derivative of the inside, which is a quotient rule, bottom, times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 1 over x plus 1 squared. So let's see, there's a 2 here. This is the square root of x plus 1 over x. That comes out to be 1. This is x squared plus 1 squared. Okay, so these two combine to give me x plus 1 to the 3/2 in the bottom, 2 in the bottom, radical x in the bottom. Okay, so this is the best final answer that we have right here. 3.643, the original was y equals x to the x. Take the ln of both sides, bring the x down in front. 1 over y dy dx, that's always going to happen for these logarithmic differentiation problems. Equals the derivative of this. First times the derivative of second, x times 1 over x, plus ln x times the derivative of the first, which is 1. Multiply both sides by y, which is x to the x. Dy dx is x to the x times 1 plus ln x. 3.441, f of t is sine squared of e to the sine squared t. Ultimately, you're squaring something, so the derivative is 2 sine of that times the derivative of sine of something, which is cosine of this, times the derivative of the inside, derivative of e to the sine squared t is e to the sine squared t, times the derivative of sine squared t, which is 2 sine t, times the derivative of sine t, which is cosine t. Okay. 3.651, y equals ln x squared plus y squared. Dy dx is 1 over x squared plus y squared times derivative of the inside, 2x plus 2y dy dx. Let's see, multiply both sides by x squared plus y squared. Looks like that. Distribute, put the dy dx is on the left. Everything else goes on the other side. So dy dx has an x squared plus y squared minus 2y equals 2x. Just divide by the thing in parentheses. So dy dx is 2x over x squared plus y squared minus 2y. 31, f of x is ln of x plus ln x. F prime of x is 1 over x plus ln x times the derivative of x plus ln x, which is 1 plus 1 over x. Okay, then I'm going to plug in 1. Put 1 here, here, and here. ln 1 is 0, so that's 1 times 2. Answer is 2. 3.9, number 3. Here's the picture. Area is 16 means x is 4. Area is x squared. dA dt is 2x dx dt. So that gives me 2 times 4 times 6, 48 centimeters squared per second. Number 9, y equals radical 2x plus 1. That's 2x plus 1 to the half. dy dt is 1/2 2x plus 1 to negative half times 2 dx dt. 2's cancel out. dy dt is 1 over radical 2x plus 1 dx dt. Part B. Plug in 5 here equals 1 over radical 2 times plug in 12 here plus 1 dx dt. Comes out to be 5 equals 1 over radical 25. That's 1/5. Multiplied by 5. Dx dt is 25. Okay, and that's x equals 4, dx dt is 3. Okay, 3.10, number 9, show that the fourth root of 1 plus 2x is approximately 1 plus half x at a equals 0. This is 1 plus 2x to the 1/4 power at the point 0, 1. The derivative is 1/4, 1 plus 2x at negative 3/4 times 2. 2 times the fourth is a half. 1 plus 2x to 3/4, plug in 0. That's 1 over 2. So y minus y1 equals m times x minus x1, or y equals L of x is 1/2 x plus 1, which is the same thing as this. Number 25, y equals e to the 10th x at x equals 0, dx is 0.1. dy is e to the 1/10 x times 1/10 dx, plug in 0.1. I have 1/10 e to the 0, 0.1, which is 1 over 100, or 0.01. 3.5, number 9. See, x squared equals y squared plus 1, x squared over y, x plus y. Multiply both sides by x plus y. X squared equals x y squared plus y cubed plus x plus y. Differentiate implicitly, 2x equals x 2y dy dx plus y squared times 1 plus 3y squared dy dx plus 1 plus dy dx. Okay. Let's leave all the dy dx's on this side, move over to the y and the 1. 2x minus y squared minus 1 equals this one, this one, this one, factor out the dy dx, divide by the factor. So dy dx is 2x minus y squared minus 1 over 2xy plus 3y squared plus 1. 3.8, number 5a. First part, p of t is 790 e to the kt. Plug in 50 here, 980 here, divide by 790. ln of 98 over 79 is e to the 50k. Take the ln on both sides. ln 98 over 79 is 50k, divide by 50. K is about 0.00431. So p of t is 790 e to the 0.00431 t. Okay, 1900 represents t is 150. Plug in 150. 1508 million or 1.5 billion. Okay, the actual amount was 1.6 billion. Number 11, carbon 14 has a half-life of 5730 years. 74% of the original is left. So half-life means 0.5A0 equals A0 e to the k times 5730. Divide by A0. You have ln 0.5, or sorry, 0.5 equals e to the 5730k. Take the ln of both sides and divide by 5730. K is about negative 0.000121. Plug that back in. Now put 0.74A0 here. 0.74A0 is A0 e to all this. Divide both sides by A0, it's gone. ln both sides. Divide by negative 0.000121. So time is approximately 2489 years. 19, P of T is P0 e to the KH. Initial pressure is 101.3, that goes there. And then for a height of 1,000 goes here, 87.14 goes there. Divide by 101.3, take the ln of both sides, and then divide by 1,000. So ln's 87.14 over 101.3, whole thing divided by 1,000. K is about negative 0.001506. That goes back over here. Now I plug in 6187. So P of 6187, 39.90 kilopascals at an altitude of 6187. 3.9, number 23. Yeah, point A, point B, 100 kilometers, 35 kilometers south for 4 hours is 140 kilometers, 25 kilometers per hour north times 4 is 100 kilometers. I drew myself this picture, right? So I have x plus y squared plus 100 squared is z squared. Plug in 140 here, 100 here. So 240 squared plus 100 squared is equal to z squared. Do the math. Z comes out to be 260. So we have 2 times x plus y times dx dt plus dy dt plus nothing, derivative of 100 squared, equals 2z dz dt. Divide both sides by 2z. And dz dt is x plus y over z times dx dt plus dy dt. The answer is in kilometers per hour. That's 140, that's 100, that's 260, that's 35, that's 25. 3.1025, estimate the cube root of 1001 using the linearization. So the function is a cube root function. X is 1/3. I'm plugging in 1,000. So I'm at the point 1,000 comma 1/10. The derivative is 1/3 x to the negative 2/3, or 1/3 x to the 2/3. Plug in 1,000. 1/3 times 1,000 to 2/3 means 1/300. Y minus y1 equals m times x minus x1. Clean it up. L of x is 1/300 x plus 20/3. Now I plug in 1,001. Plug in 1,001, 10.003 repeating. Is our approximation. 3.5, number 5. X squared minus 4xy. Think of it as plus parentheses negative 4xy plus y squared equals 4. Differentiate implicitly. 2x plus negative 4x first function times the derivative second dy dx plus second y times the derivative first negative 4 plus 2y dy dx equals 0. Derivative 4. Throw that over. Throw that over. So the right side is 4y minus 2x. Factor out the dy dx. 2y minus 4x. Divide both sides by 2y minus 4x. So dy dx is 4y minus 2x over 2y minus 4x. To clean it up, factor out the 2 from here on out and then cancel the 2. Number 7. Again, differentiate implicitly. 4x cubed plus x squared 2y dy dx plus y squared times 2x plus 3y squared dy dx equals 0. Anything that doesn't have a dy dx goes over, like that one and that one. Factor out the dy dx from these two. So dy dx times 2x squared y plus 3y squared equals negative 4x cubed, that moves over, minus 2xy squared. So dy dx is negative 4x cubed minus 2xy squared, all over 2x squared y plus 3y squared. 21, f of x plus x squared times f of x cubed is equal to 10. F of 1 is 2, find f prime of 1. Differentiate implicitly f prime of x plus product root x squared times 3 times f of x squared times f prime of x plus second function f of x cubed times derivative of first is 2x equals 0. Plug in 1, f prime of 1 plus 1 squared 3 times f of 1 is 2 squared, f prime of 1 plus f of 1 is 2 cubed times 2 times 1 is equal to 0. Okay, so these two combine to be f prime of 1 plus 12, f prime of 1 plus 16, 13 f prime of 1 excuse me, plus 16 is 0. So f prime of 1 is negative 16 over 13. 3.619, do a little bit of log work first. So this can be written as a ln of e to the x times 1 plus x, which is ln e to the x plus ln 1 plus x. That's the same as negative x. So now I differentiate negative 1 plus 1 over 1 plus x. Okay, y equals tangent of all that. Derivative is secant squared of all that times derivative of this, which is 1 over ax plus b times a. Okay, 23, y equals square root of x ln x. So first function times derivative of second, 1 over x plus second times derivative of x to the half, 1/2 x to the negative 1/2. Touch it up, x to the negative half plus 1/2 x to the negative half ln x. Factor out the x to the negative 1/2. And then I have 1 plus 1/2 ln x. X to the negative half means square root of x. Multiply top and bottom by 2 just to make it look nicer. So 2 plus ln x over 2 radical x, or 1/2 2 plus ln x over radical x. So double prime is 1/2 bottom times derivative of the top plus the top times derivative of the bottom, all over the bottom squared, and etc. You just clean that up a little bit afterwards. Let's see, 3.435. Y equals cosine of all that. Derivative is negative sine of all that times the derivative of all that, which is a quotient rule. Bottom times derivative of the top minus the top times the derivative of the bottom, all over the bottom squared, and just clean that up eventually. 37, cotangent squared of sine theta, outside function squaring. So 2 cotangent sine theta times derivative of cotangent, which is negative cosecant squared sine theta, times derivative of sine theta, which is cosine theta. Okay, 43, the only variable is x. R is a constant, A is a constant, P is a constant, N is a constant. So the derivative is P, 2RA to the RX plus N to the P minus 1 times the derivative of the inside, which is 2RA to the RX ln A times R. As a reminder, derivative of A to the X is A to the X ln A. 17 looks like a product root and chain root. So derivative first times derivative of the second, 5 times x squared plus x plus 1 to the fourth times derivative of the inside, chain root 2x plus 1, plus second function, just copy it, times derivative of the first 4 times 2x minus 3 cubed times 2. And then just clean up simple stuff like 4 times 2 is 8. 33, g of x is 4 raised to the c over x, which is c x to negative 1. So g prime of x is 4 c over x ln 4 times the derivative of the exponent, which is negative c x to negative 2. Clean it up, negative c ln 4 times 4 to the c over x, all over x squared. 25, 3.5, y sine 2x equals x cosine 2y at this point. So product rule, y times cosine 2x times 2 plus sine 2x times dy dx equals product rule, x times negative sine 2y times 2 dy dx plus cosine 2y times 1. Okay, plug in pi over 2, any occurrence of x, pi over 4, any occurrence of y. So pi over 4 goes there, and pi over 4 goes there, well, if you double, you get pi over 2. And over there, that's pi over 2. And plug in every x is pi over 4. 2 times that is pi. Sorry, you plug in pi over 2 for x. So plug in pi over 2 here, that's pi. That's going to be pi. That's pi over 2. Okay, so let's see, clean it up. Sine of pi is 0, that's gone. Cosine of pi is -1. So pi over 4 times -1 is negative pi over 2. Cosine of pi over 2, that's 0. That's -1, so negative pi over 2 equals negative pi over 2 dy dx, so dy dx is 1. So y minus y1 equals m times x minus x1. .127, g of q is 1 plus q to the -1 squared. So g prime is 2 times 1 plus q to the -1 times the derivative of the inside, which is -1 q to the -2. And a little bit of touch up, you can write it like that. 21, the derivative of this, a, b, and c are constant. So the derivative is 3a u squared plus 2bu plus c. 3.211, it's much easier to distribute. So FOIL it out. That is y to -1. That is 5y. That is -3y to -3. And that is 15y to -1. So the derivative is -y to -2 plus 5 plus 9y to -4 minus 15y to -2, etc. What is the etc.? Just make all the negative exponents positive exponents. 19, divide through. S divided by s squared is s to the -1. Negative radical s over s squared is negative s to the -3/2. So the derivative is -1 times s to the -2 plus 3/2 s to the -5/2, etc. Clean up no negative exponents. Okay, quotient rule. So bottom times derivative of the top plus the top times the derivative of the bottom. There's a double negative, so I can change to a positive. All over 1 plus cosine theta quantity squared. Clean it up, distribute the top, cosine theta plus cosine squared theta plus sine squared theta. This is all 1, and it'll cancel one of these, so final answer is 1 over 1 plus cosine theta. Okay, 19, the derivative of cotangent. Think of it as cosine over sine prime. So bottom times derivative of the top minus top times derivative of the bottom, all over the bottom squared. This is negative sine squared minus cosine squared. That's -1 over sine squared or negative cosecant x. 31. The derivative is bottom times derivative of the top, secant squared x, minus the top times derivative of the bottom, secant x tangent x, all over secant squared x. Okay, a little bit of touch up. Divide that by that, you get secant x. Divide that by that, you have negative tan x minus 1 times tangent x all over secant x. And you can clean up even further, get a common denominator of secant x. So this becomes secant squared x minus tangent squared x plus tan x over secant squared x. This is 1, so 1 plus tan over secant. Change everything to sines and cosines. 1 plus sine x over cosine x over 1 over cosine x, multiple top and bottom by cosine x. So you're stuck with cosine x plus sine x. Part B, treat f of x as sine x over cosine x minus 1 over 1 over cosine x, multiply top and bottom by cosine x. So you get sine x minus cosine x, whose derivative is cosine x plus sine x, which is the same thing as we got over here, but this was a lot easier to do. Okay, limit theta approaches 0, sine 3 theta over theta. You want this to match this, so I multiply by 3 over 3, take the 3 out. So I have limit theta approaches 0, sine 3 theta over theta. I snuck in the 3, although you don't have to, but that makes that one, and that one all match. If theta goes to 0, 3 theta goes to 0. This identity we recognize as 1, so 3 times 1 is 3. Okay, let's see. F of x equals 2x cubed plus 5x. At x equals 1, find the equation of the tangent line. Plug in 1, you get 7, so we're at the point 1 comma 7. F prime of x is 6x squared plus 5. Plug in 1, you get 11. So y minus y1 equals m times x minus x1. To make it into L of x, the linearization, just solve for y equals L of x, 11x minus 4. Okay, approximate f of 1.1. plug in 1.1 to L of X, comes out to be about 8.1. Okay, 3.5, number 9, we did tackle that before. 3.647, y equals cos x raised to the x. Take the ln of both sides, the x comes down. 1 over y dy dx equals product rule. First times root of the second, 1 over cosine x times negative sine x, plus second function, ln cos x times root of the first, which is 1. Multiply both sides by y. Dy dx is cosine x to the x, the original y, times negative x tan x plus ln cosine x. Okay, one other one, y equals 3 over x squared plus 5x minus 16. Find the derivative. Think of it as 3 times x squared plus 5x minus 16 to the negative 1. So y prime is negative 3, x squared plus 5x minus 16 to the negative 2 times the derivative of the inside, 2x plus 5. So negative 3 times 2x plus 5 all over x squared plus 5x minus 16 squared. So these are some problems for review for chapter 3.